Everybody, so in this video we're going to learn how to use the Planisphere. So in your lab I'm talking about this part, so from page 4 until page 8. So for this we're going to use the Planisphere. So that's a tool that will allow you to recognize constellation when you go outside without the need to have a software with you right away. This is also a tool that we can use to predict which constellation will be visible at any time of the year. So on the Planisphere tutorial, you'll see you have first a few general questions to answer. Like you will see that on your Planisphere there is a little white thing that you can turn on the side, and there is only one part, one star on your Planisphere that is not rotating. So really, before getting into this, take the time to look at all the detail, all the text that you have written on the Planisphere, really get familiar with it. So now let me show you a little demo. I'm going to stop sharing the screen here, and let me show you a short demo of the Planisphere. So the first things you want to pay attention to is the latitude. On the Planisphere, you'll see that yours should correspond to 40 degrees of latitude north. We're using those Planisphere because Mount SAC is located in Los Angeles, which is at 34 degrees of latitude north. So as you have seen in the previous lab on Starry Night, depending on where you are on Earth, you will see different constellations. The constellation that you see at the North Pole are not the same that you see at the South Pole. So when you use a Planisphere, you always need to check that you're using the one that corresponds to your latitude. If you were to move to Argentina, you will need a new Planisphere. This Planisphere will not work in the southern hemisphere because there is different constellation in the southern hemisphere. From that previous lab, you also saw that the altitude of Polaris change with the latitude. So depending on where you are in the world, your Planisphere will have Polaris at a different location, would move in latitude, in altitude. So make sure, if you bought your own, make sure that you bought the one from 30 to 40 degrees of latitude north. So now, how do we use this thing? So you'll see there is a little rotating white wheel, and along the circle you have a lot of you have dates, and you have the time. So let's say that today is January 15. The year doesn't matter for what we're doing here. So let's say it is January 15, and we want to observe the sky at 9 p.m. What you will do is you will rotate the date here, and you will put January 15 in front of 9 p.m. So you have midnight in here, 9 p.m. is at the bottom. I'm just going to rotate and put January 15 right in front of the 9 p.m. If you can see what I did in here. So now that you get that, what you see here is the sky at 9 p.m. on January 15, that you will see if you are anywhere between 30 and 40 degrees of latitude north. Now, if you're outside, how do you use this? The outline here, the outline of this map represents your horizon. So if you are facing north, what you will see on the horizon will be those constellations. So you'll have Ursa Minor, the little deeper, kind of hanging down in there if you're facing north. Toward the middle in here, actually, most of you should have like this line on your planisphere. If you got it from Monsac, you'll have an X. The X is representing the zenith. So this is the horizon. This is what you have right above your head, the zenith. And as you continue toward here, you're looking toward the south. So behind you, if north was in front of me. On those planisphere, the south sky is actually behind. So on January 15 at 9 p.m., if you are to look toward the south, you will see those constellations. So Caelum, Orlogium, or Columba, or Puppis constellation toward the southern horizon. As you go up in there, you're looking more and more above your head. You also have the east and the west. So everything rise in the east, set in the west. This is your meridian line. So if you go outside and you want to look at the eastern horizon, you need to rotate this. Let's say east is, so if north is there, east is that way. So if you're looking toward the east, you would put the word east toward the bottom. And you will see that you should have the constellation Leo partially above the horizon. Above your head, you'll have Auriga and Gemini. If you're looking toward the west, you rotate your planisphere to have the west word at the bottom, and you'll see the Pegasus constellation on the horizon. As you look up, you'll have the Perseus constellation above. So remember, this point marks what is above your head. So that's how you use the planisphere. If you want to look at the sky on May 10th at 12 p.m. At noon, 12 p.m. So let's say midnight. If you want to look on May 15th or May 10th at midnight, all that you do is that you will rotate, but May 10th in here at midnight. That is the sky that you will see. Right above your head, you would have Corona Borealis. So now how to find out which constellation is rising, which constellation is setting. So a constellation is rising when most of the stars are above the horizon. For example, let's take a look at the Andromeda constellation. The Andromeda constellation here, so we're looking toward the east. The constellation has completely risen. This way, we only see Andromeda partially. You cannot consider it rising yet. You have to wait until all your stars are at least above the horizon to consider that Andromeda is rising. So now if I ask you on at what date Andromeda, well, let's say on April 15, at what time will the Andromeda constellation be rising? Well, then you will put Andromeda on the east horizon, and you will look at the corresponding date. So if we're looking at April 15, you will see that Andromeda is rising at about 4 a.m. On the Planisphere, also be careful to check daylight saving. If we are in a time during daylight saving, you have to subtract 1 hour. So all the time on the Planisphere are in standard time. Daylight saving is that time that we use during the summer. So as you will see, I was saying rise in the east, set in the west. So on April 15, what time is Andromeda rising, setting? So it sets when it is on the west. And you see here, though the stars are not completely above, those are the two last stars. You can consider that Andromeda is set in there. If we look back to April 15, you will see that the constellation will set at around 9 p.m. So always, when you ask for a date, always look at the corresponding time that this date is facing. So that's pretty simple to use the Planisphere. Know if you are in daylight saving or not. So for the winter semester, we are not. We're using standard time, so you don't have to subtract an hour. Put the date that you're observing in front of the time that you want to observe to, and you will see the sky that you should have above your head. One more detail on the Planisphere. You'll notice there is lines. Remember your celestial sphere coordinates, those equatorial coordinates, right ascension, declination. What you will see here, this line, you will see, so this line going from Polaris to the horizon is your declination, how far you are from the celestial equator. So hopefully the pole is at 90 degrees of declination, and as you go toward the horizon, you will encounter the 0 degree hour. Once you go to 0 degree of declination, you have this other circle, which is your right ascension circle. This one is given in hour, minute, and seconds. So using those marks, you can also read the celestial, the equatorial coordinate of every object in the sky. For example, let's look at the star Vega, part of the summer triangle. So if we look at the star Vega, so put the star Vega on the meridian. This is something like this. You'll see the star Vega on the meridian. It's almost at the zenith. Can you tell me at which date Vega will be at the zenith at midnight? For this, you'll read midnight. We are looking toward June 28th. So on June 28th, Vega is at the zenith. Now for the coordinates. Vega, so let's start with declination. You will see that Vega is very close from the 40 degree declination. It's a little bit less than 40. So let's say it could be very well 39 or 40 degrees of declination. And for the hour, you will read it on the corresponding circles. So the hour would be 18 hours and 30 minutes. Those are the celestial sphere coordinates and the equatorial coordinate of the star Vega. 13 hours, 30 minutes of right ascension, and about 40 hours of declination. And so that's about everything you need to know to work on the Planisphere. one word of caution. So the name of the constellation are written in capital. For example, you'll have, I think this one is Hercules. You'll have Hercules, that's the name of a constellation. Lyra is the name of a constellation, Sinus as well. Everything that is lowercase is a star. For example, Deneb is the name of the star. Same thing for, well, everything that is lowercase is either a deep sky object or a star. Deneb is a star, Altair is a star, Betelgeuse is a star. M13 is a deep sky object, it's a globular cluster. M31 is the Andromeda galaxy that you can see right here. So don't confuse name of stars and object with the name of the constellation, which are in uppercase. So now let's go back to your tutorial, to your lab for a moment. So you'll see you also have the same instruction, what I showed you here, written on your lab. So you'll have to pick the date at which you're doing the lab, set it up for 9 p.m. on that date, and tell me which constellation you see on the horizon and at the zenith. Make sure you do not miss the southern horizon here. Then you'll do some exercise to read right ascension and declination coordinates of stars. And then you look at some more specific type of objects. We talk about Orion or M31, M13. And there is a few tables to complete there. For example, I give you a date and a time. Tell me when the constellation is rising, which one is rising, which one is setting, which one is toward the north on that particular date and time. Then we'll do the opposite exercise. I give you this time a constellation. Tell me when it rises and when it sets, which date, which time. So this is, once again, this is a tool that becomes very handy when you are in the field and you don't have access to software. Now you noticed this is in equatorial coordinates, and this is only for stars and deep sky objects. Solar system objects do not have fixed coordinate in the sky, like planet, comets, all that travel faster across the background sky. So on your planisphere, you will not have the planet or any solar system object. For those, you do need a software and you do need to plan ahead. If you want to know the coordinate of those, you will not be able to use the planisphere for solar system object. You use this only for constellations, stars, and deep sky objects. And with that, good luck trying to use the planisphere, and I encourage you to go outside as much as you can with it. Practice, practice, and practice. It's with practicing this that you will understand better and better how to read this. Really correlate that with what you see outside. It's super important to do that multiple times to get a good grab on the planisphere.